Yeah, welcome to lesson 7 of the ABAP Cloud Developer Series, and in this lesson we are declaring and working with complex internal tables. Of course, we have seen different types of internal tables so far. If you are new to this channel, please also watch lesson 1 to lesson 6. And by the end of this lesson, the objective is that you'll be able to declare complex internal tables, choose the right table type, and then fill them with data. You can also read data efficiently using index and key access. So let's get started. So the first thing we're going to do is to create our console application. So let's open Eclipse. You just go ahead and create a package. So right here, I'm creating this package. So next, and let's create a new transport request. So all Cloud Tutorial Series objects that we create will go into this transport request. Let's click on finish. So now we have this package created. So to create the console application, just like previous lessons, we'll start with a global class. So let's create a global class in this our package. So we can add this package to favorites. Just right click on it and then say add to favorite packages so you can easily access it. So inside this package, let's create a global class. Just right click on the package, go to new ABAP class. So let's call the name of our ABAP class complex tab. Put the name right here. So we can give it description, complex tables, and say internal tables. Let's add the interface if_OOAD class run. So this allows us to run the program directly in Eclipse ADT. This one, double click, next. Yeah, we select this transport request that we created earlier, click on finish. So now we have the class definition, public, final. If you don't want inheritance, create public section. Our interface is here. We have protected section, we have private section. Then this is the class implementation that implements the interface that we added to it, right? So in the step 2, we define a structure row type. A complex internal table always starts with a structure, so there has to always be a structure, and each structure represents one row of the table. So think of this structure as maybe one flight connection record. So let's go to the Eclipse and create our structure type. So inside our implementation class run, we create the structure type, and so we are creating a structure of ty flight. So this structure has components in it. We have actually done this before, so I will not spend much time explaining this. So each component, so these are components, each component becomes a column and the structure itself becomes a row. Okay, so this is reusable and readable. So I will show you an example shortly to actually know the difference between the complex table and a simple table. So a simple internal table you can define like this using data, give a variable, then type table of I. This is integer. So this has only one unnamed column. It is just used for basic scenarios. But if you are to define a complex internal table, you say you use this data lt underscore, let's say these are variable, and then type table of ty flight connection. If you are looking at a table has columns and rows. So if you look at a structure, think of a structure like a row. So if you define an entire structure, this means this is one row. So and when you have a row, you have columns inside that row, right? So see this component as the columns for one row. Okay, so if I want to define a simple internal table, I do not need to define a structure. I can just use a data type that already exists. So data lt numbers, type table of integers. So this is a simple internal table. So this is used for basic scenarios. And if you want to define a complex internal table, you define that internal table based on a structure that you already created. Okay, so we're going to define an internal table based on this structure ty underscore flight underscore connection. This right here is your complex internal table based on the structure you define. This right here is your simple internal structure based on existing data type. So when we are talking of internal tables generally, there are also different types of internal table. You have the standard table, you also have the sorted table, and you have the hashed table. So if you want to define a standard table, you can just say data, the variable name, then type standard table of your structure. You have to add standard, of course, with non-unique default key. So let's look at it in Eclipse. So we're looking at now the internal table types, and the first internal table type is the standard table. So to define a standard table, the keyword type standard table of should be there. So you have data, define the variable name, then say type, standard table of, give the name of the structure with non-unique default key. So this means that there is no automatic sorting. Okay, so if you use standard table, there is no sorting. Then you also have fast index access, and there's also slow key access on large tables. So when you use this, then you have slow key access on large tables. By default, if you use type table of, it uses standard internal table. Okay, then the second type of table is a sorted table, and to define the sorted table, you have to have sorted in the definition or in the declaration. So you have data, the variable name, you have data lt underscore sorted, then type sorted table of, give the name of the structure with non-unique key from airports, then to underscore airports. So what this means is it's always sorted by key. So this is a sorted table. You sort it by key. And when you do sorted table, you have faster key access than standard tables. So you can easily access the table, and insert position is automatically calculated. Okay. Then the third one is the hashed table. So it has to have hashed in the declaration. So data lt hashed type hashed table of t1 underscore flight connection with non-unique key. With unique key rather, airline ID, flight number. These are components from our structure. So what this gives is you have faster key access, and when you use this, no duplicate is allowed and no index access. So index is invalid. You don't use index here. Let's go ahead now and look at how to define a local table type. So a local table type means that instead of just repeating long table definition, we can just define a named table type. Okay, so if you want to define the table type, use the keyword types and then give the name that you want to give the name for that table, TT. That if you see TT, it means table type. Then you have flight. Then the type will be, let's say we want to create a sorted table type. Let's use sorted table of, and then give the structure name T1 underscore flight underscore con, and then you can say with unique key, airline ID, flight ID. So it will be sorted based on this unique key. And so to define, so for reusability, you can just say that data lt underscore connection type tt underscore flight connection. So you can just reuse this table type whenever you want to define this structure. And so we'll move further to explain what a work area is, right? So for complex table, the work area must be structured. So the best practice is to use like line of. So to define the work area is a data ls underscore connection. These are work area, and then you use like line of lt underscore connections. So it will take the structure that it will define in the table type. And so if you want to fill the work area and append, you give the work area name and use hyphen and then fill in the component. Likewise here, see if I do ls underscore connection. So if you put hyphen, it gives you the columns that we have or the components. So if I want to add airline name, just double click on this and say equal to, so flight number, let's say 0400, put a period. You can likewise do ls connection. If you put hyphen again, it gives you the component. So here will be flight number, double click, equal to, let's say France. So I'll just fill up the other ones. Okay, so we have 2 airports and airline name. So after we fill the work area, what we need to do, we need to append to our table type lt connection. So use the keyword append the work area ls underscore connection. Use the keyword to our table type lt underscore connection. All right, when you save this, if we use the debugger to inspect the table, to use the debugger, you can just highlight or double click on the line. So you can see that I've made a toggle. You can just right click and say toggle breakpoint. You add a breakpoint to this line. So, and then you can just execute. It should trigger the debugger about application console. Yeah, before then it did not trigger because we did not save. So let's save and activate. Ctrl S, Ctrl F2, no errors, Ctrl F3. So let's activate and run again. So now you have the debugger, right? So you can view the content of the LT connections. You can, if I click on F5, this is LS connection. This is the content in LS connection, and this is LT connections, our table type. So when you double click, you see the data in the table. So you see that the structure is a row and the components are the columns for that row, all right? So you can play around the debugger to see the content of the work area and also for the table. So this is how to work with simple internal table structure and complex internal table structure, and you can also play around. Of course, there are also ways you can fill up your work area and append. Let's just click on F8 to end the debugger section. Then you can click right here to go back to the ABAP perspective. Alright, so another modern way that ABAP allows us to append rows without using work area. So if we don't want to create this work area, you can just use the value. So let me comment out this. Comment this out. So when you use append value, then write the name of the structure. So append the values to this structure and then just give the component airline_id, AF, flight number, from airports to airports, airline_name to this table. LT connection is our table. So we are appending these values based on this structure to this table, and this table is a table type. Okay, let's put a breakpoint here, double click on this line, and let's control save, check, syntax check F2. So ignore these 7 errors you are seeing for now. I'm working on another project and there were some errors there I needed to fix. But for this particular example, there are no errors. So Ctrl F3 activate and let's run to trigger the debugger. So in debugger mode, you can double click on our table, LT_connection. So when you double click, you get the table data down here. So if I drag this up, see that the contents have been appended or added to it without using a work area. So this modern way of how you can append. So you can also see the content right here on the right, LT_connection table. We have airline ID, flight number from airport. So if you want to add another row, you can just use the append without creating a work area. And so you can see append value, ty_structure. So let's just change this one to AS 1021 CDF JFKE. Can just say Marok. Alright, so let's save this. Let's check, activate. Let's execute this. ABAP console application. So this was the first row. So let's do F6. So F6 takes us to the second row that I want to add. So let's do F6 again. So if we check the table, LT connection table, double click on this. You now see the content, first row, second row, double click and you take it up. You now see that I have 2 rows to the table. So these are how you can add rows to your table without using the work area in modern ABAP. So this one, your code is shorter, less memory usage, and is preferred for modern ABAP programming. Okay, so another way to fill up the table, we can just click F8 now to exit the debugger and select here to go back to the ABAP perspective. So let me comment out this. So you can actually fill up the entire table at once. Fill up the entire table at once. Okay, and how can you do that? You can use the value hash to fill up the table. So you see here, I call the name of the table LT_connection, use the value hash, and then write the components or the columns for each row. So airline ID equals to LH, flight number, then from airports to airports, the value, airline name, the value. And so each row is in a bracket. And then the second row, you can also add a third row by just copying the components or the columns and changing the values. LA, say 3, ZHR, AFK, can just say in Indian Airways. The disadvantage of, or one thing you should take note about using this is the existing entries are deleted. So if there are entries that exist, they'll be deleted and the new entries will be added. And secondly, the tables are always rebuilt from scratch. So whenever I use this value hash, the tables are rebuilt from scratch, unlike the other tables that you can keep appending or keep removing. All right, so another thing we should also do here is how to copy data with corresponding. We have also done this before. So if you want to copy data, we use the corresponding keyword, and here we are defining our table type, our table. So data LT carriers, table type DMO_carrier. So this, if you click on F3, so this is a table that's already been defined. Flight reference scenario carrier. So we can use the table to define or give a structure to LT carriers. Okay. and then we can say LT connection is equal to corresponding LT carriers. So it will copy only identical named fields and extra fields are ignored. So it's only the fields that are identical to LT connections that will be copied. All right, and we've done this also in the previous video. You can also see an example of this. And next is how to read data from complex tables. So to read data from complex table, you can use the keyword read, to read only one record. So you can say read table, you give the table name, LT underscore connection, index 1 into LS connection. So you are saying the first index, read it into LS connection. So it will retrieve the first row of the table into LS connection. And this is very fast and works only with standard table and sorted tables. So you can also use key access. Okay, you can also read data using key access. So you can play around with this, read the data, debug in the debugger mode. So using key access, we can say read this table with key, airline ID and flight number. So this is going to be our key that is going to be using, and into this work area, LS connection. Performance will depend on the table type and is best with sorted or hashed table. So in summary, the complex internal tables are the backbone of real ABAP applications, and once you understand how to declare, fill and access them properly, you are already writing production ready ABAP. So if you like this video, please hit the thumbs up and subscribe. See you in the next video.